Hello, my name is Ryan Tulloch and I am the President of ProDelta Projects. I would like to thank you for joining our webinar, and today I'm going to talk about the integration of remote sensing into facility and pipeline integrity programs. ProDelta is a turnkey integrity service provider, and we do this through a very simple systematic approach. Our approach is identify, plan, and execute. Utilizing a series of remote sensing systems, we can identify potential hazard areas from the convenience of the office. From weather tracking to live feed cameras, our single interface can help clients identify these areas without the cost of mobilizing staff. Using both manned and unmanned aircraft, we can complete detailed inspections of facilities and pipeline right-of-ways. With our high-resolution cameras and additional other sensors, we can generate a single source of data that can be reviewed by multiple stakeholders to come up with a solution. ProDelta's team can collect data and develop design solutions. An example of this service is depth of cover surveys and creek revetment design. Using a variety of different sensors and working with qualified engineer, ProDelta's developed solutions that are both cost-saving and approved by regulators. We also complete 3D modeling of sites, which better allows stakeholders that are not familiar with the complexities of integrity work to visualize and better understand the required revetment. With a fleet of heavy equipment, ProDelta can complete integrity digs on MPS 3 to 48 inch. We execute the highest level of safety and environmental standards and adhere to local, provincial, and federal guidelines. Today's short webinar will focus on how we use remote sensing to identify and plan, and we'll also touch on 3D modeling. ProDelta's developed a desktop monitoring system that incorporates weather. Weather is one of the most inconsistent things to monitor and the hardest thing to predict. So with our live radar feed here, we can start looking at where weather systems are impacting clients' infrastructure. So I'm going to go ahead and zoom into an area where we have a client's infrastructure pulled out of a database. And we can start looking at the weather system that's tracking over it. This gives a priority area to other things to look for. Further to this, we've developed a flood monitoring system for all of Canada. Today I'm just going to focus on in Northeast BC as we're actively working for a client up in this area. So I'm going to go ahead and turn that on. So there's two parts to it. There's the water meter stations as well as the water basins. The water basins upgrade every hour and are programmed to are programmed for the 1 in 50, 1 in 100, and 1 in 200 year floods. And everything is color coded based on that. Red indicates that a 1 in 200 year flood is happening, and when we update it, we also get a list of parameters that comes in, as you can see here. Here's your water meter ID, when it was updated, discharge level, and the flood status. In addition to that, if there's any questions, you can quickly and easily click on any one of the water meter stations and bring that in to review it. So by clicking on here, we can see that the snowpack looks like the snowpack is starting to let go, and the water level is quickly rising. The purpose of this tool is to prioritize inspection areas based on weather events. So we can zoom in now with the red water basin zoomed in and look at the pipeline infrastructure in that area. By bringing in the creek layer, which we can do very easily, we can start prioritizing areas and get down to the coordinates of where we should be dispatching aircraft. If it's a smaller area, we could look at utilizing a UAV, as that may be more cost effective. In this situation, it would probably be the best cost-effective way is to deploy a helicopter with a camera system looking for any erosion areas. Additionally, if there was known slide areas or other geotechnical concerns, we could also be doing aerial inspections on those and bring that into the monitoring system as well. ProDelta completes a large amount of pipeline patrols for regulatory compliance. Our staff are specialized in this, and we don't use pilots to do the inspection. We work closely with our helicopter pilots and providers to do this. However, we believe that the best inspection we can do is have one person focus on inspection and one person concentrating on the flying. When we're doing our inspections, we look for a variety of things such as right-of-way activity, including construction, public encroachment, third-party crossings, unapproved work. Additionally, we look at environmentals as erosion, flooding, leak detection, vegetation growth, and unstable ground. Additionally, any surface spills or signage at signs we'd obviously record. We complete a detailed spreadsheet as a turnover package, as well as we do a large amount of photographs. So here's an example of a photogrammetry survey that we also used to do a right-of-way inspection for a client, saving them money. So when we zoom in to specific areas, we can see that we have a large amount of photos focused around the pipeline right away. Due to the focal length, just because the camera icon doesn't show it right above the pipeline doesn't mean we didn't capture it. As we click on it, it's photo to point. We can see that we do have a bunch of surface water collecting on this, which may be causing erosion. This would be identified in our report and given to the client for them to make their decision. Our approach to this is we do a desktop review looking for all regulatory anomalies that should be existing, such as signage at roads, crossing, approved construction that may be happening in the area, and we go out to the field with a plan and verify rather than just an inspection. We find that because of the amount of data that we collect in a day, this has been the most cost-effective, best inspection that we can give. ProDelta utilizes the unmanned aircraft quite a bit. With the high-resolution cameras and low operating costs, we can complete a very detailed survey and patrol and inspection of any object. However, with Transport Canada regulations, we do have to follow those, which includes visual line of sight at all times, landowner permission to take on and off their property, and due to the nature of them, they are a little more susceptible to adverse weather conditions such as high winds and rains. However, in the right condition, they are a great tool. From pipeline inspections to right-of-way cleanup costs to flare tip inspections, as you can see here. We can utilize a FLIR camera mounted as well, which in this example we've done a compressor heat loss, looking to ensure that no heat was going. Another use for this would be using the UAV to look for cold spots under insulation before getting crews up, as well as checking out the flare igniters to ensure all of them are lit. The UAVs are becoming an intricate part of ProDelta's we do a lot of 3D modeling system, and we use them for depth of cover surveys. In addition to the 3D, we do standard depth of cover surveys where we measure in the pipe and complete a surface and profile of the pipe and compare them, as well as do revetment based on 2D. However, on more complex sites, the 3D model does help out. Here's an example of how we use photogrammetry UAV survey by flying a UAV on a grid pattern. Utilizing correction, we can actually collect a UAV point cloud with 2 to 3 centimeters accuracy. In addition to this, we get a nice 3D mesh and a high-resolution orthomosaic of 1.2 centimeters per pixel. Next, I'm going to show you how we integrate the point cloud data and stratigraphic layers into a conceptual 3D model. An interesting project that we completed was actually a 3D model that included subterranean data. We did this utilizing existing borehole and SI data, and then extrapolated that into stratigraphic layers. So as you can see as we zoom in, this is the 3D point cloud, which is extremely high resolution and great detail. As we go up, we can start seeing the 3D features on it. By turning off some layers, by taking off the point cloud, we can start seeing the stratigraphic layers that we brought in. You see the clay till, and as we zoom in, the yellow and blue lines indicate pipe that's actually representative into scale. In addition, on this one, we had slope indicator data, which we did model in 3D. To show it, we did do an exaggeration of about a 10 to 1 because there was very, very little movement. But as you can see, we have the events that every SI event extrapolated in there. After that, we extrapolated the potential slide plane in here and to see where it intercepted with the pipe. As you can see, here is a potential of where the pipe is pipe intersects the potential slide area. From this, our client can make a decision if it's worthwhile to install strain gauges on the pipe and minimize the risk of a failure during a slide event. This was a great project in which we were able to use a variety of instruments from UAVs, manned aircraft, flow meters, and GNS survey equipment to generate this 3D model. This has helped the client mitigate some of their risk decisions and determine what the next stages are in the risk with the pipeline. Interactive panoramics is another great tool we utilize when generating any of our integrity plans. Utilizing UAV technology, we take a series of photographs and merge them into one single interface which can be interacted by our clients. With no special software required in the computer, we can immerse them as if they were there. This is done in all of our projects as we find this a very valuable asset in our toolbox. Well, I hope you enjoyed our introduction on how we've integrated remote sensing into the pipeline and facility integrity programs. We really just touched the tip of the iceberg and some of the stuff we're working on. If you have any questions, please feel free to contact myself at any time, and thank you again for joining us. Have a great day.